So, now as we talk about sleep, we're not talking about normal sleep. This is going to be dysfunctions that exist in sleep. The first is going to be narcolepsy. And narcolepsy is a very bizarre disorder, but in narcolepsy, an individual can spontaneously enter into REM sleep. Now, one thing I didn't mention to you earlier was, when we talk about sleep, the body goes through those 4 stages of NREM before it enters into REM sleep. So, you start off in stage 1, go to stage 2, you can come back to stage 1, go to stage 3, you can come back to stage 1, then stage 2, stage 3, stage 4, and then eventually to REM sleep. Individuals with narcolepsy can actually just be talking and then, I'm sorry, I must have narcolepted out on you. So, narcolepsy is associated with going from being awake to being asleep, and actually having delta waves generated in rapid eye movement sleep. The second dysfunction is insomnia, and insomnia can be brought on by a whole host of things. Everything from what you ate to serious physical ailments that cause narcolepsy, including mental disorders. So insomnia can be brought on by a whole host of things, but insomnia is going to be sleeplessness. It's going to be difficult for a person to actually not only get into NREM, but to get into REM sleep. And that is a very, very frustrating process because it leaves an individual very tired and fatigued ultimately. And then the last dysfunction that I want to talk to you about is sleep apnea. Sleep apnea is going to be an individual that during the course of the night is going to have trouble actually getting enough oxygen. Now, sometimes an individual with sleep apnea is going to stop breathing completely, and this is not just going to lead to an individual being fatigued and tired, but it can lead to death. So sleep apnea is a very serious dysfunction. But these are all 3. Narcolepsy, insomnia, and sleep apnea are all associated with disorders involving sleep. Slide number 19 is going to talk a little bit about language. Now, as far as language areas in the brain, there are 2 areas I want you to be familiar with. One I talked to you about earlier, and that was Broca's area. Remember, that exists inside of what we would refer to as the motor cortex. The second area that I want you to be familiar with is an area called Wernicke's area. Now, it's spelled with a W, W-E-R-N-I-C-K-E. And Wernicke's area is going to be associated with language as well, but a different kind of language concept than Broca's area. Broca's area is going to be important as far as speech recognition. So that is your ability to hear and comprehend speech, for you to be able to identify what speech or what language a person is speaking. Wernicke's area is going to be important as far as actually doing the talking. So true speech is associated with Wernicke's area, not Broca's area. So damage to Wernicke's area, an individual can understand but may be mute. Damage to Broca's area, a person may be able to speak without being able to understand the language that they're speaking. So these are very, very interesting areas of the brain, language. And then the second area that is associated, or the second portion of what I want to talk to you about as far as language is concerned, is going to involve memory. Now, this is not just for language memory, this is memory overall. Remember, the hippocampus is a very important structure as far as learning and memory is concerned. There are 2 types of memory. There is short-term memory and there is long-term memory. Now, short-term memory is going to serve kind of like a reservoir, and that reservoir, your brain is going to evaluate whether the information is important or not, whether it is essential or not, and if it's not, then it will be discarded. If it is essential, then the brain will retain it in the form of long-term memory. There are as we talk about dysfunctions associated with learning and memory, of course amnesia is what comes to mind. And when we're talking about amnesia and the ability to remember things that have happened, or whether it's recently or in the past, there are two types of amnesia that exist. The first is anterograde amnesia, and anterograde amnesia is going to describe amnesia from this point on. So from the time that a person has anterograde amnesia, they're no longer able to make memories that they can turn into long-term memory. So an individual sustains some sort of a head wound, and this injury, when I say a head wound, it results in brain damage. And the damage that it causes impairs a person's ability to continue to have new long-term memory. Then there's retrograde amnesia, and retrograde amnesia is that a person it's not that they can't make new memories, it's that they don't have any of the memories from the past. So maybe from the time of insult, from the time that they received a specific injury. So moving on to slide number 20, we're going to talk about protection of the brain, and specifically in the form of the meninges and cerebrospinal fluid. The meninges are going to be a tough, fluid-filled sac that covers the brain. Remember, it exists in 3 different layers. The dura mater is the outermost layer, and it is going to be very tough and fibrous and thick. And there's going to be a subdural space associated with it. There is an epidural space that is located between it and the skull. Now, these meninges are going to cover not just the brain, but also the spinal cord. The dura mater is the outermost, the toughest, most fibrous layer. There is a subdural space that exists under it, or deep to it, just above the arachnoid. And the arachnoid is going to be the second major space. The arachnoid space is going to also be called the arachnoid mater, and it has a fluid-filled component as well, called the subarachnoid space. The innermost layer that adheres fairly tightly to the brain is referred to as the pia mater. So pia mater closest to the brain, then subarachnoid space, the arachnoid, subdural space, the dura, and then eventually the epidural space and the the cranium itself. Cerebrospinal fluid is generated by the choroid plexus, and the choroid plexus is going to be found inside of ventricles. So if you look like in the 4th ventricle, you'll see the choroid plexus, which is important as far as the production of cerebrospinal fluid, and then it's going to be moved along by ependymal cells through the ventricles. As it is circulated through the ventricles, it is going to be circulated and produced at the amount of about 150 milliliters per 8 hours. So your body produces about 150 ml of cerebrospinal fluid every 8 hours, which leaves us a grand total of about 500 mLs per day. So 500 mLs of cerebrospinal fluid a day for production, and 150 mLs per 8 hours. We'll move on to slide 21 next.